2-1. This is the second worksheet we're going to be talking about today. We're going to be talking about evaluation and domain and range. So with that being said, a function rule. A function rule is an equation that represents y in terms of x. This, y equals negative 3x plus 6, is a function rule. This is a function rule of 2x minus 5, meaning when I plug in a value for x, I can chug out an answer for y. We have the independent x value corresponding to the dependent y value. Okay? Now, function notation is another way to represent y. So you get rid of the y, and in place of it, you simply put f of x. It's kind of like calling me Mrs. Yoder instead of calling me Kendra, because it's respect. It's just saying it's a formality. This is a formal notation for f of x, or for y equals. So if you have y equals 2x, function notation is now going to be f of x equals 2x plus 3. That's all that is. So it says write the equation y equals negative 9 plus 4x in function notation. Get rid of y, and in place of it put f of x, and then you just simply put negative 9 plus 4x. That is function notation. Replace y with f of x. Okay? Now, using functional notation used for the evaluation of a function. We always use function notation whenever we're evaluating functions. That is pretty much all it is used for. So if I give you f of x is equal to y is equal to negative 2x plus 5, I'm telling you that all of my y values, which is f of x, correspond and are dependent upon whatever x is by multiplying it by negative 2 and then adding 5. And I want to know what the output, aka y value, is for my input, aka x values. Okay? So basically what you're doing is you are simply plugging and chugging the values negative 3, 0, and 1/4 in for x. And then you're going to chug out an answer. So I give you f at negative 3. F at negative 3 is taking negative 2x plus 5, which is my function, and every place you see an x, plugging in negative 3 to give you 6 plus 5, which is 11. Now that's going to pop out an ordered pair of negative 3, 11. Now, I believe we did this already whenever we did section 2.4, and we did piecewise functions and evaluating. It's exactly the same procedure. So now I'm going to do f at 0, so this is negative 2 times 0 plus 5, which is just going to give you the 5 to give you 0, 5. And the last one, this is going to give you negative 2 times a fourth plus 5, which is going to be the same thing as negative 1/2 plus 5, which is going to be the same thing as 4 1/2. Okay? So again, we have already done this whenever we did our piecewise functions with our function notation. Okay? So we're going to probably skip a little bit of this. What is the output for the given input? Simply plug in negative parenthesis 2x plus 1 over 3. The negative either goes to the top or the bottom. Always put it with the number in the bottom, and simply evaluate. 2 times negative 2 plus 1 over negative 3. That's a negative 4 to make me a negative 3 over negative 3, which is a 1. Okay? Same thing, 2 times 0 plus 1 over negative 3. That's going to give you a negative 1/3. Okay, we're going to skip the rest of that, and we're going to keep on going. Interval notation. Okay, now this is the actual meat and potatoes of this section. We're talking about domain and range. Remember I said domain responds to x, range corresponds with y. Domain we read from left to right, and range we read from bottom to top. Okay? There are two types of notations we're going to be using, interval and set. Set has the braces, interval has parentheses and brackets. So, notation, interval notation looks like an ordered pair. It is not an ordered pair. It is a starting point going over a period of several values with an ending point. So 5 to 25. Okay, it's going to look like an ordered pair, but it's not. The first number is where the function begins, and the second number is where the function ends. So you have starting point and ending point. You can have a parenthesis or you can have a bracket. What's the difference? Parenthesis means the value is excluded. It's used with less than and greater than symbols. Okay? Brackets mean it is included and it's used with greater than or equal to or less than or equal to symbols. Okay? Brackets means it can be it, Parentheses means it cannot be it, okay? So if I have negative 3 is less than x, which is less than or equal to 7, that means I'm going to have a parenthesis at negative 3 because it's strictly less than, and it's going to be a bracket at 7, meaning it can be 7, okay? The largest in the number in the world is infinity, and the smallest number is negative infinity. So that is interval notation. Set notation, you must have braces. And you have to tell me what number family you are talking about. The number families could be the real numbers, the integers, the rationals, or the irrationals. For this purpose, we are always in the real number family. And the real number family is written with 2 lines down and make an R out of it. 2 lines down and make an R out of it. Okay? This symbol right here is what we call a curved D, or make a C with a line in the middle. Make a C with a line in the middle. It means it's a member of. So X is an element of the reals. The bar is the such that, and then you're just simply going to tell me the inequality that we would be dealing with. That's set notation. Now, domain. I said before, domain is read from left to right, and you're going to find the smallest x value that it responds to a y value, and that's the starting point. Then you're going to find the largest x value that has a corresponding y value, and that's the ending point. Same exact thing for the range, except for you're reading it from bottom to top. So the bottom is going to be the starting number, and then the top is going to be the ending number. Okay? So let's do this. Now, I need your brain to understand something. We are going to be talking about arrows. And arrows mean they go on forever and ever and ever and ever. This is an arrow and this is an arrow. That means it is going to go up off of this board, into the ceiling, out of the building, into the sky, out into outer space, and it's going to go up forever and ever and ever and ever and ever and ever and ever. It's going to get wider and wider and wider and wider. My arms are going to open up bigger and bigger and bigger out in space. Okay? That means as soon as you see the arrows, those arrows mean that this x value is going to go on forever and ever in both directions. So the smallest number is going to be negative infinity, and the largest number will be positive infinity. What this means is there are no domain restrictions. So that means I'm going to say x is an element of the reals, and there are no domain restrictions. So when you see double arrows like this, it goes on in both directions, and it can be anything it wants to be. Okay? Now, interval. Well, where does it start? Parenthesis at negative infinity and go all the way to positive infinity. Okay? Now, range. How do I read range? I read range from bottom to top. So I'm coming up here, and where do I first run into the graph at? I run into the graph right here. What y value is that? The y value that is going to be 0. So that means this thing starts at 0, and then where does it end? Where does the graph end? It's all the way up in the sky, remember? So that means it ends at positive infinity. So I always have to have a parenthesis around the infinities, but I'm going to have a bracket at 0, because that 0 means it can be it. Okay? So that's my range. Well, what do I say this is another way? It can be any y value as long as it is what? Well, I'm going to say it's going to be in my real number system, and it can be anything as long as it is greater than or equal to 0. Okay? Let's do it again. Find the domain and the range. Okay, domain. I'm chugging along here, and what x value do I run into this graph at? I run into this graph at this value right here, -3. Then when do I stop running into this x value? I stop running into the graph right there at +3. And it can be both of those values, so that means you're going to have brackets. Interval notation is super easy compared to set notation whenever you're looking at this. Set notation means x is an element of the reals. But whenever you have this, it's trapped. So -3 is less than or equal to x, which is less than or equal to +3. You have to use the less than or equal to symbols because they are brackets. Okay? when x is trapped, you're always using the less than symbol, but the less than or equal to here because of the brackets. Okay, so let's change colors here. And now I'm on the y-axis, and when do I run into this? I run into it right here, and that y value is going to be -1. And then when do I stop running into it? I stop running into it there at +1. So now I'm talking about my y values. So it's going to be y's in elm of the reals such that I have exactly the same thing. So it's going to be -1 is less than or equal to y, which is less than or equal to +1. Okay? You can use a comma or you can use a line there. It doesn't matter. Let's do it again. Find the domain and the range graphically of the graph. What do you see right here? Arrows. That means it's going up, 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 and off the graph. It's going down, 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 and off the graph paper. So it's going forever in both directions. So since it's going forever in both directions, are there any domain restrictions on x? The answer to that is there are no domain restrictions, which means x can be anything it wants to be because it has a corresponding y value to it. Now, if there's a corresponding y value to it, that means it starts at -infinity and goes all the way to +infinity. Okay, well, what about the range? Well, I'm all the way down here, and I see that this has a corresponding y value here, 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 and it just keeps going, doesn't it? So this, because there's arrows in both directions, is still going to be y's in elm of the reals. Why is it y? Because it's range. So therefore, it's going to go from -infinity to infinity. Tonight's homework is 2-1, worksheet 2, evaluation, domain, and range.